Hey class, let's do some more domain problems. These problems are from your notes. We did not quite get there, so I'm going to make sure I go through examples 5 and 6 from you in your binder. And then I might, if there is time, I will maybe do one from the homework, but let's see how long these ones take. Okay, so here is the deal. Just like the last steps, you essentially are going to do these steps every time, where you're finding the domain of the inside function, and then you're finding the composition, and then asking yourself, are there further restrictions? So for this, the square root function is square root of x plus 2, so we're finding f of g of x. So remember, the first step, you want to find the domain of the inside function, which is the square root function in this case. So the domain of the square root of x plus 2 is when we take the inside of the square root and we say, hey, that has to be positive. So it has to be greater than, or it could equal 0. So the domain of this is x is greater than or equal to -2. If you are a visual person and you like to see what that looks like, it looks like this. That's going to be a filled in circle on -2 because we could equal 0, and then going to the right forever. All right, so that is from -2 to infinity. That is the domain of the square root function. We're going to come back to that, so we want to keep it. The second part is to find the composition. So we are going to plug in this function to the x and the other f function. So we have 1 over the square root of x plus 2 and then minus 5. And I'm not going to make you guys simplify that anymore, so that is the composition. Now this has a further restriction because the bottom cannot equal 0. Okay, so we need to do the further restriction here. And so we got to get x by itself. So let's go ahead and add this 5 over to the other side. So what we have is the square root of x plus 2 cannot equal 5. Now square both sides. We got x plus 2 cannot equal 25, and subtract over the 2. So x cannot equal 23. Okay, so now we have two, and let me draw that out, sorry. We have two different restrictions going on, and again, we're just going to take the intersection. Okay, so 23, and so x cannot equal that, so it can equal anything but. So that's -infinity to 23, and then 23 to infinity. So now we're just going to take these two and we're going to find the intersection. Where do they overlap? So we have -2 and we have 23. I'm not counting tick marks here. So let's see. This one is filled in circle going this way. And the 23 was an open circle, but anything else. So where do we overlap? Well, we overlap in a couple spots. We overlap starting at -2, but then we do not overlap at this open circle, and then we overlap forever going this way. So the green is my final domain, which is going to be from -2 to 23, and then from 23 to infinity. And so that is the domain of the composition. So the two green answers, the two green boxes are the two answers to this problem. This one is the composition, and this one is the domain of the composition. Okay, so that's pretty complicated. Let's do example 6. I think this one's a little bit better. And then we will see how much time we have after that. Okay, so for this one, we want to start by, well, we're going to be finding f of g of x. So let's find the domain of the inside function. So this is step 1. We take the inside of the square root, x minus 1. It has to be positive. So x is greater than or equal to 1. So that's going to be a filled in circle on 1 and then going to the right. I just skipped right to the function notation there, but I will draw an overlap at the end. I meant interval notation. I think I said function. Too much math today. All right, here we go. We got f of g of x. So I'm taking g of x, and I'm plugging it into the x here and here. So we have the square root of x minus 1. We're squaring that, and then plus 4x. And I'm plugging in square root of x minus 1 for x there too. So the square and the square root are going to cancel out. So here I just have an x minus 1 plus 4 root x minus 1. And this is it. This is the composition. There's nothing else I can combine there. So I'm done. This is the composition. And there is no further restriction here. Okay, there is no further restriction because there's no fraction. Yes, there is the radical, but we already found the domain of that radical. So look what it says in the instructions. If there is no further restriction, then the domain is the same as step 1. So this domain is going to be the same as step 1, and I'm done. Okay, so in your homework, they give you a bunch of functions. Now, I highly suggest you find all of these domains. Now, I'm doing these quick, but for this one, we're going to have x is greater than or equal to negative 8. So that's negative 8 to infinity. The domain of anything linear is negative to positive infinity. Same thing with any polynomial. Here, x cannot equal 10. So that's going to be negative infinity to 10, and then 10 to infinity. And here, this is an absolute value equation, so the domain is negative to positive infinity. Once you know those domains, I really do think these are going to be faster. So, like for the n of p of x, they're both negative to positive infinity, so that will be the domain of the composition. Let's see, r and n. Those both have a domain of negative to positive infinity, so that's what the composition will be. 13 you might struggle with, but we can go over that one in class. Q and N. Okay, there's one where we have a rational with a linear, so we could do that one. So Q of n of x. So I always like to start by just finding the inside domain, which is negative to positive infinity. So there's no restriction on my inside domain, which means all I really have to do is find the domain of the final answer. So let's do that. I'm going to plug in n of x, which is 1 over x minus 10, to my q function. Oh, I'm sorry. Oh, I got these backwards. My bad. I'm sorry. I'm plugging in n, which is x minus 5, to the q function, which is the 1 over x minus 10. So 1 over, instead of x, I'm plugging in x minus 5, and then minus 10. So combining like terms, my final answer here is 1 over x minus 15. So I do have to find the domain of my final answer. But since the inside function did not have a restriction, I don't have to do that step 1 where I find the initial restriction. Okay, so x minus 15 cannot equal 0. So x cannot equal 15, which means x can equal anything else. So we will have negative infinity to 15, and then 15 to infinity. That should be the domain. Okay, so that's really all I want you guys to do. Try the other problems here, see how it goes, and we can go over more in class. Thanks, guys.